other than running blank solution, you prepare your blank solution and run it and then do corrected signal, what can be done to correct the background in AAS? We have one method, i.e. using a continuum source for background corrector. Okay, specifically is using high energy deuterium background corrector. So remember, in UV visible spectroscopy, we use D2 lamp, okay, to produce the radiation for UV. Okay, it is the same deuterium lamp once again. Okay, but how D2 lamp will help to correct the background? Okay, so this is the normal HCl in AAS, and then we have the sample, and then we have the same monochromator, and then we detector. But the extra part is this D2 lamp as well as chopper. The existence of chopper in here is very important because it actually will produce the alternating pulse of radiation from the D2 source and hollow cathode lamp. Okay, means that D2 lamp over here is actually coming into the system to help to correct the background by subtracting the background signal inside it. Okay, so in any AAS, in software, they will be supplied with the equation that we calculate all this pulse between the D2 lamp plus hollow cathode lamp and pulse of the hollow cathode lamp only. So because of the difference, it can produce the signal that is actually not biased. Okay, not all instruments available with D2 lamp. So when we are buying AAS, for example, okay, I would suggest you to buy with D2 lamp as the background corrector. Okay, let us see a video produced by Department of Chemistry and in National University of Singapore. I think the video is very straightforward and will help you to understand how D2 lamp helps to correct the background. Okay, so this is the one. Yeah. Okay. Okay, this will be repeated several times. Now you see the chopper, okay, is open. Yes, the signal is at the lower part, and then the chopper close. The HCl radiation will go into the flame, and then same D2 lamp will also go to the flame. Means that whatever HCl encounter, D2 lamp will encounter as well. So that makes it enable to correction. Okay, now it's like normal lah. Okay, open, HCl go up, D2 lamp will go here. So kat sini it will be corrected. Okay, close once again. Okay, HCl coming here. Okay, we want HCl to be coming from here so that all your atoms will absorb. Okay, because of this difference between the signal, okay, the equation inside the computer will able to like give you the signal that is not biased. Okay, this is an old method actually, but we have a more straightforward and also more complicated, but it is giving you more sensitivity. That's what we call as Zeeman background correction. Okay, you can read on your own for Zeeman background correction. Okay, and basically it is almost the same principle, okay, but the setting is way complicated. Okay, let us resume on the non-spectral interference. The first non-spectral interference is matrix interference, classic interference that will happen to any instrumentation, even though for even though it is common, it is actually a classic interference because the difference between the surface tension and viscosity that given by the matrix, or what we call as rubbish lah. Okay, that's why sample preparation is very important to be done. So in AAS, okay, the sample preparation will focus on the preparation of inorganic analytes. Okay, because so far we have been discussing about inorganic elements. Okay, no more compound, no more molecular compounds, unlike in UV, fluorescence and phosphorescence. So matrix interference is more imminent or more significant in atomic absorption spectroscopy because we will use digestion. Okay, digestion and filtration. Okay, later we will learn at the I think week 7 good. Okay. So what can be done to correct the matrix interference? We can matrix match all the sample. So I believe you already learned this in principle of analytical chemistry. Means that you match the matrix in the sample, standard and blanks. If let's say your sample is seawater, your standard must be prepared in seawater. Your blank must also contain seawater. Okay, means that you are matching everything, means that everything is treated fairly, and let us see what is the signal given with the matrix as background. Okay, so this is taking into account all the matrix. Okay, if sample face problem matrix interference, standard must do so, blank also must face the same thing. Okay. And then we have chemical interference. So this is the first matrix interference. And then we have chemical interference. Okay, chemical interference, it is actually because of the analyte itself. Okay, because of the analyte itself, whereby if let's say the analyte is very thermally stable, okay, that will not decompose with any typical available in the flame. Okay, remember we learned about the fuel oxidant list kan? Okay, we have air acetylene, we have nitrous oxide acetylene, we have all those natural gas and air. Okay, so those are the list that is available at certain temperature. If let's say you have thermally stable, the best thing is to use higher temperature flame. But when the temperature flame is very high, okay, sometimes it will create another problem, what we call as ionization. Okay, remember we don't want ionization to happen because the atoms available to absorb the radiation will be less. So the fastest one is to use higher temperature flame with some precaution not to start or not to initiate ionization. But what if you don't? Okay, you said, okay doctor, my lab doesn't have any nitrous oxide acetylene gas that fuel oxidant that can give 2500 degrees C. You can always put a complexing agent. This EDTA will help to reduce the stability of the thermal, or you that's what we call as releasing agent, okay, to the free atom to be produced in the flame. Okay, that's the chemical interference. And then we have ionization interference. Ionization interference is related to this one lah. Okay, the temperature of the flame is too hot, okay, and will create ions lah. Means that you have more ions as compared to atoms. Whereas you want atoms more, right? You want atoms to be able to absorb and then detected by detector. If ions, macam mana dia nak go towards higher energy level because it's already in the higher energy level. Okay, this will lower the absorbance. Okay, what can be done if you have ionization interference? You can add potassium over here, potassium solution, which is an ionizable element, easily ionizable element, whereby potassium yang akan ionize, okay, not your analyte. Means that is that the sacrificial element lah, the sacrifice. Okay, this easily ionizable element will add a surplus of electron to the solution to shift towards the production of ground state atom for your analyte of interest. Okay, so that's all for atomic absorption spectroscopy. We will move forward to the sample preparation. Sample preparation that is suitable for atomic absorption spectroscopy.